Hey everyone, happy Monday. It's Mr. Boothman here again. I thought we'd start the week by doing an unboxing of an instrument that I recently acquired. So let's jump right in. Okay, it comes in this lovely little cloth pouch. Okay, let's pull this out here. And these are called chapa. They're hand cymbals. Brand new. Look at how gorgeous these are. They're quite loud, so I don't want to actually play them. You can see the pin that holds the handle to it, okay? Held like this around either your pointer or your middle finger here. Keep your thumbs loose, the rest of your fingers loose. Oh, these are lovely. I'm very excited to be able to perform with these. Those of you who came to my performance, you have seen how I play them. Now, it is important to keep these clean. That's why this microfiber cloth is going to be incredibly useful here. If you don't polish them after each use, then the oils on your fingers tarnish the metal. We don't want that to happen. We want to keep these as clean and fresh as they are now. We'll just finish polishing these up. I'm just so excited to be able to use these. Need to figure out how to turn this over without actually touching it here. Put that back in its pouch there for when I play them. All right, well, that was quite fun. I look forward to using these. Still working on my fouet skills. Looking forward to being able to perform that in the future as well. All right, well, let's go ahead and move over to our lesson. I'll see you guys there. Happy Monday, it's a new week. All right, well, we have to start today with some important announcements. And that includes details about your culminating activity for this semester. Okay, so instead of your EOCA, instead of an exam, you are completing a culminating activity, okay? This is different depending on each class. For this class, okay, your culminating activity will take the form of a free response exam, so you're not actually getting out of an exam, consisting of 6 multi-part questions, okay? So this exam is posted along with the place to submit it. So open that document. There are six questions. Each question has multiple parts, A, B, C, whatever. You'll submit your work and your answer for each question completed on separate paper to the Google form that I, again, shared on Google Classroom with the exam document. That is shared today and will be due by the end of the day on Friday, May 8th, 2020. This will be worth 20%. I'm sorry. This will be worth 10% of your semester grade. Okay, 10%. These questions are similar to questions we've answered throughout the year. Okay, so none of it is like a surprise to you. None of it should be completely new. I did my best to make them kind of AP style. So each question does have a theme. Each part builds on itself, and you'll be assessed accordingly. Okay, you're free to use your notes, any old tests, a calculator, any other resources you'd like, except other people. So it's open note, open book. Please work individually. Okay. Again, I know I can't police that, but I'm trusting you. Don't let me down. Here's how you'll be graded. So each question, as you can see on that document, has an associated rubric. Okay, So I will score each of your questions using that rubric. Your overall exam score will be the average of those rubric scores, rounded up to the nearest 0.5. So let's look at an example. You have 6 questions, okay? Suppose that on those 6 questions you score a 2, 3, 2, 4, 2, and a 2. So not terrible scores, not amazing, but not terrible. Your overall exam score would then be the average of all of those numbers. So add them all up, divide by 6, and your exam score that I would put into the gradebook would be a 2.5. Okay. So that score is weighted 10% of your semester grade. Remember that a 2.5 is equivalent to an 80% in the gradebook. So this is the same as you getting an 80% on this final. Okay, so that's what that looks like. Truly, I'm not trying to lower any of your grades with this. Okay, it's open note. These questions should be very manageable for you. Okay, I want to see some high scores here. It shouldn't drop your grade. Okay, I want to encourage you to do this and get your work done. Okay, but it does include content right up through the end of this year. That includes our next unit, so make sure you're still engaged. So join our Google Meet today with any culminating activity questions you might have. And then each day, if you have questions that come up, go ahead and ask me. I will answer clarification questions, but I'm not going to help you on the problems themselves. Okay, so if you ask me, how do I do this? I'm not going to help you. Okay, it's like a final. In addition, you do have a normal exit ticket for the day. That will be to submit any questions you might have about Unit 8. That will be due by midnight tonight. Tomorrow is our Unit 8 exam, which means today we're completing our Unit 8 review. So each of the following slides has 1, maybe 2 problems. Complete the problem, then check your answer with the answer key or with this video. Okay, let's jump right in. Find the first 4 terms of the recursive sequence. Okay. Recursive sequence, again, that means that the nth term is defined in terms of the numbers that come before it. So we have to start with a specific term. In this case, we're told that the first term equals 1. We want the first 4 terms. They gave us the first. To find the second, that's going to be 3 times a, plug in 2, 1, plus 5. The first term is 1. So our answer is 8. The third term, it's 3 times the second term plus 5. So 3 times 8 plus 5, which is 29. And finally, the fourth term is 3 times the third term plus 5, or 92. Okay. So again, check your work. Recursive sequences, hopefully not too bad. Find the 11th term of the sequence. So here is our sequence. Find the 11th term. That means we need the nth term formula. So we need to determine what kind of sequence this is. How do we go from 3 to 6? Well, we're either adding 3 or multiplying by 2. But that rule has to apply each time. 6 plus 3, that's not 12. 6 times 2 is 12. So that means we're multiplying by 2 each time. 12 times 2 is 24, so we found our rule. We're multiplying, which makes this a geometric sequence. Our first term is 3, and our common ratio is 2. That means the nth term is 3 times 2 to the n minus 1 power. So if we're looking for the 11th term, we have 3 times 2 to the 11 minus 1 power. That's 3 times 2 to the 10th power, which equals 3072. Okay. Moving on. I am going a bit quickly through these. Find the nth term formula and the 8th term of the arithmetic sequence whose third term is 4 and 17th term is negative 24. Okay. Well, it's arithmetic. We're told that it's arithmetic. So that means the nth term is a1 plus n minus 1 times d. And we're told that the third term is 4. And if we were to write that out using our nth term formula, we'd get this. And the 17th term is negative 24, which is this. All right. We don't know A1, we don't know D, but we have two equations with two variables. Let's set up this system of equations. 4 equals A1 plus 2D, and negative 24 equals A1 plus 16D. I'm going to use elimination, subtract the second equation from the first. We get 4 plus 24 is 28. A1 minus A1 is 0. 2D minus 16D is negative 14D. Divide both sides by negative 14, and we get D equals negative 2. Knowing that D equals negative 2, we can plug that into one of these equations to solve for A1. We get A1 equals 8. So we want the nth term formula. That's 8 plus n minus 1 times negative 2. And we want the 8th term. The 8th term is going to be 8 plus 8 minus 1 times negative 2. 8 plus 7 times negative 2, okay, negative 14 plus 8, negative 6. Okay, so hardest kind of question that you can come across with these types of problems, just remember to set up your system of equations. It's not too bad after that. Okay. Now let's look at a fun word problem. I do love a good word problem. A theater wants to know how much money it will make if it sells out for a particular show. Each ticket costs $25. The first row of seats has 20 seats. The second row has 24 seats. The third has 28, and so on. If there are 20 rows, can you help the theater figure out how much money it would make? Well, here's our sequence. 20 seats, 24 seats, 28 seats. So what are we doing to get to the next term? We're adding 4. That makes this an arithmetic sequence. Now, if we want to know the total amount of money we would make, we know the cost per seat, so we need to know the total number of seats. In other words, we need the sum of this sequence. There are 20 rows, so we're looking for the 20th sum, the 20th partial sum of this arithmetic sequence. Now this is arithmetic. We know A1 equals 20, and we know D equals 4. So that means AN equals 20 plus n minus 1 times 4. 20th partial sum, we're using our partial sum formula for arithmetic sequences. That's n times A1 plus AN all over 2. N is 20. A1 is 20, and we need the 20th term. Okay, so how do we find the 20th term? We have this nth term formula. 19 times 4 plus 20 gives us 96. So we plug this back in. 20 divided by 2 is 10. Times 20 plus 96. So how many total seats? 1,160. Each ticket is $25, so the total amount of money this theater would make if they sell every single seat is 25 times 1,160. Or $29,000. Okay. So word problem, not terrible. It's just pulling out the relevant information and making sense of it, like any word problem in math. Okay, check your answers. Let's continue. Find the 20th partial sum of this sequence. How are we getting to the next term? are adding 4. That makes this arithmetic. A1 equals 1, D equals 4, so the nth term is 1 plus n minus 1 times 4. The 20th partial sum is S20 equals n times A1 plus an all over 2. A20 is 1 plus 20 minus 1 times 4. Adding all of that up, we get 19 times 4 plus 1, which is 77. Plugging that in here. 20 times 1 plus 77, all over 2. Okay. 20 divided by 2 is 10. Times 78 is 780. Okay. Please note, in this answer key, I did make yet another mistake. I'm sorry. There's a lot to keep track of these days, okay? So your answer is 780, not 380, okay? I made a mistake when finding that 20th term. Okay, so please note that. All right, let's continue. Find the 7th partial sum of this sequence. So how are we getting from one term to the next? Looks to me like we're multiplying by 3. This is a geometric sequence. A1 equals 2, R equals 3. That means the nth term is 2 times 3 to the n minus 1 power. 7th partial sum, so S7. Partial sum of a geometric sequence. Again, we check our reference sheet. That is 2 times 1 minus R to the nth power, so to the 7th power, all over 1 minus 3. We plug all of this into a calculator. We get 2186. It's just a matter of using the formula. All right. Last few problems. Write the following series in sigma notation. We're adding, so we know we're using our sigma. How do we use the term number to get the term value? Okay. Well, there's always a 3 in the numerator. So any term has 3 in the numerator over, all right, here's another sequence of numbers hopefully you start to recognize. 1, 8, 27, 64. These are the perfect cubes. For the first term, we're taking 1 cubed in the denominator. The second term is 2 cubed. Third term is 3 cubed, and so on. So starting at k equals 1, we're taking k cubed in the denominator, and we're continuing to infinity. Okay, so breaking it down piece by piece. Sigma notation. Again, that'll be for highly proficient score. Finally, find the sum of the infinite geometric series, if possible. So let's do each problem separately. 3 plus 9 over 2 plus 27 over 4 plus. The key to infinite geometric series, our common ratio must be between -1 and 1. The absolute value of r must be less than 1. How are we getting from one term to the next? 3 times what is 9 over 2? 3 over 2. And does that work here? Yes. So r is 3 over 2. The absolute value of r then is the absolute value of 3 over 2, which is 3 over 2, which is not less than 1. So this doesn't have a sum. The sum just doesn't exist. Okay, it just continues forever. It keeps getting larger. Part B. Okay, now we need to pull out the relevant information here. What are we multiplying by each time? That's whatever we're raising to our exponent. So that is 1 over 4. So r equals 1/4. absolute value of r is the absolute value of 1/4, which is 1/4, which is less than 1. So this infinite geometric series does have a finite sum equal to a1 over 1 minus r. What is a1? Well, we're going to find that by plugging in our first k value. When k equals 1, we have 2 times 1/4 to the 1 minus 1 power. 1 minus 1 is 0. 1/4 to the 0 power is 1 times 2 is 2. So a1 is 2 over 1 minus 1/4. That's 2 over 3/4. Dividing by fraction is multiplying by its reciprocal, so 2 times 4 over 3, which is 8 over 3. There you go. So continue practicing, make sure you did all of these problems. Go back through the review problems for 8.1, 8.2, look at those independent practices I posted. Complete your exit ticket by midnight tonight, and tomorrow we have our Unit 8 exam. Okay, join our Google Meet with any questions. See you later. All right, well, that was today's lesson. I sure had fun sharing that with you. Just keep up with your work. Let me know if you have any questions about anything, and I'll see you tomorrow.